Hey everybody, Dr. Nelson here. This is a video about what is a rational number. So we're going to take some notes with me at first, and then there'll be some problems for you to try, and then at the end you can see how you did. So just what exactly is a rational number? All right, well, if you look at the word rational right here, the word ratio is part of the word rational. All right, and ratio should be a term you've heard before, and a ratio is basically a fraction. All right, so rational numbers can be written as a over b, where a and b are integers and b is not 0. So basically a rational number is any number that can be written as a fraction. So let's say we have the number 3/5. Well, 3 is an integer and 5 is an integer, so 3/5 is a rational number. A rational number can also be, say, in decimal form, because say if we have the number 7/10, well, that's a decimal, but this also equals 7/10. So because we can write the decimal 7/10 as a fraction 7/10, it's rational. Because again, 7 is an integer and 10 is also an integer. A number like say 1.5 is also rational, because 1.5 can be written as an improper fraction, which is 3/2. And again, we have a fraction where the numerator is an integer and the denominator is also an integer. Alright, so now let's talk about decimals that are rational numbers. Alright, this is a key thing. Rational numbers that are decimals must either terminate or repeat. If you please underline the word terminate and also repeat and put a little star next to that. This is key. Alright, so for example, the number, let's say 0.42. Alright, well, that absolutely terminates, right? It stops. And we know that this can be written as 42 100ths. And 42 100ths, 42 and both 100 are integers, so it's rational. It also could repeat. Say, for example, if we have 0.3 with the repeating bar. Well, this really means 0.333333 and so on. And we know that this fraction equals 1/3. Because if I did 1 divided by 3 in a calculator, I would certainly get 0.333 repeating. So let me give an example of a number that's not rational. Let's say if we have this decimal. Let me use red for a second here. Let's say if we have 0.487146 ... So what this means is these dots means it keeps on going forever. If you notice, there's no pattern to this. It goes 487146. Who knows what the next number is going to be? All right, so because it doesn't terminate or repeat, this right here would not be a rational number. So let's take a look at the box over here. It says, which of the following numbers are rational? Well, this first one is, because 12 and 1 are both integers, so this is rational. The second one, -8. Well, -8 can be written as -8 over 1. And again, -8 and 1 are both integers, so this one is definitely rational. This one here, we have 0.88888 and so on. Well, this obviously is repeating, and again, over here we know that decimals that repeat are rational, so this one also is rational. 1 and 4/5. Well, we know we can write 1 and 4/5 as 9/5. And 9/5 is a fraction where both the numerator and denominator are integers, so that makes this one rational. Now pi, pi is the most is not rational. It's called irrational. In fact, it's the most famous irrational number out there. And you should know that pi goes 3.1415 ... and goes on forever. It doesn't terminate, and certainly does not repeat. So this one is not a rational number. And then finally, we have 0.43256 ... So again, this goes on forever, and it's not repeating, so this is definitely not a rational number. Alright, so now that you understand what a rational number is, why don't you pause the video and try the your turn problems now, and then when you're done, hit play. You can see how you did. Alright, good luck. Alright, welcome back. Let's see how you did with these practice problems. So I've already gone through and I've circled all the numbers that are rational. And let's just talk about why. So -4/9, well, both 4 and 9 are integers and it's negative, that's fine. So this certainly would be rational. Same thing for 2/7 and 9/5. Okay, both the numerator and the denominator they're all integers, which makes them rational. -50 we could write as -50 over 1, which makes that rational. Here over here we have 0.252525, and this terminates, and it also repeats. So just the fact that it terminates makes it a rational number. Now here we have a number that's going on forever, but notice it's repeating. So that makes this also rational. And finally we have the square root of 16, and the square root of 16 we can write as 4, because 4 times 4 is 16. And again, 4 can be written as 4 over 1, which makes it rational. So we only had two numbers that were not rational. This first decimal here, which goes on forever and does not repeat. And then same thing here, we have 3.14156. Again, the number goes on forever and does not repeat. And there it is. All right, how'd you do?